Hi, I'm Ken Carter, Professor of Polymer Science and Engineering here at the University of Massachusetts, and welcome to my research group. What I'd like to do first is just tell you a little bit about myself. I was trained as an inorganic chemist originally, and then I went on after getting my PhD to work in a large corporate research lab working on advanced materials and microelectronics. In 2004, I moved to University of Massachusetts, and I kind of continued on those same types of themes in my research. And so the kind of things that we're interested in my group are advanced materials, surface modification of materials, and really just being able to design and synthesize and create materials that have specific functions and polymers that have specific functions. For example, one type of polymer that we're very interested in and do a lot of work with is a material called nanocellulose. And nanocellulose is basically the basic building blocks of cellulose, which algae, wood, and other things. And it's a completely sustainable material. So we're interested in if we can take this material and modify its characteristics and enable its use in a bunch of different applications. In my group, I have people that are chemists, I have people that are engineers, I have people that are interested in physics, and about half my group like to make things, make in terms of chemistry, synthesize interesting materials and then characterize them. And the other half of the group like to actually make things out of those things. And so looking at making and fabricating devices and testing their function. So that's a little bit about me and my group and what we do. So now let's take a look at the labs.
Cellulose is the most abundant biopolymer in the world and has been used in a lot of different applications, from the clothing we wear to even as a food additive. And so our group thinks that there's a lot of untapped potential with cellulose, and we want to take advantage of the strong mechanical properties that this material has. With the 3 hydroxyl groups per cellulose monomer, this means that we can do a lot of different chemistries on the cellulose and modify this material. So within our group, we have explored a lot of different areas using cellulose, from carbon dioxide capture to anti-fogging, and even in sustainable electronics. My research has been focused on using cellulose for anti-fogging and in chemical warfare protection applications.
So, as Justin was talking about, cellulose is used in a wide variety of applications. My research has been focused on using cellulose for carbon dioxide capture. And so in order for my project to be successful, I've had to use a wide variety of chemistry techniques to modify cellulose for CO2 capture, as well as employ a lot of processing and engineering techniques in order to make these materials useful in CO2 capture. And so, as most people are interested in whether or not this material works, and so with the help of some collaborators, I've had to build this custom instrument where I can measure CO2 absorption in real time, and I'm very excited to see where this project will continue to go.
In our research group, we always have people coming from a diverse scientific and personal backgrounds, and this always results in us helping each other with our respective research projects, especially when so many of them are interdisciplinary and require many different perspectives. And so that always helps us reach very good results and do very good science. So we end up helping each other by reviewing each other's papers and coming up with new ideas, and that always leads to very fruitful collaborations, not only within the group, but also with other groups in the department, as well as international collaborations.
I hope you enjoyed the tour of the laboratory and hearing about the types of things I do in my research group. We're a very congenial group, like a little family, and I welcome you to contact me by phone or email, or come visit us at the university, and hopefully you come here to study with us and join our little happy family in polymer science and engineering.